Hello, hello, hello. Good morning. So today we will be seeing applications of NDT. Our fourth unit in the syllabus is non-destructive testing, and we will continue with what we have done last time. So just to give you a brief about non-destructive testing, I'll start the topic with few images that will be later on discussed as some of the testing methods and results of these testing methods. Okay, you are seeing few images over here. Here some number is there. So this is a thickness measuring instrument. The second image shows dark pink points or lines on a white background. The third image shows a brown colored, rounded, and clustered of powder on the metal piece. Thereafter, one more image where some measurement is being done. Again, we have a very beautiful image of defect wherein the defect is visible as fluorescent green color. Thereafter, we have a screen of equipment where we are able to see some micro elements, that is evaluation analysis of the chemical composition of some material, right? We'll discuss these images again when we see these images during study of various testing methods. Okay, so briefly classifying non-destructive technique. Broadly, it is classified into two groups: surface defect detection technique and volumetric defect detection techniques. The techniques marked in red are going to be studied, or we will be studying these techniques in details, whereas others, which are marked in black, will be given to you or discussed in terms of quick overview, just for the sake that you should know the names and principle and where it is used. That is enough. Dye penetrant testing, magnetic particle testing, eddy current testing, infrared thermography, all these are surface defect detection techniques. Okay, what do you understand by surface defect detection? So it detects defects that are open to the surface or just below the surface. Okay, so you cannot detect any defect discontinuity that is within the material. The defect needs to be open to the surface either in small size or a large size. Okay, thereafter volumetric defect detection techniques: industrial radiography, ultrasonic testing, neutron radiography, acoustic emission, and leakage testing. Now, these methods or techniques are used for detection of defects throughout the material, that is, throughout the volume of the material. In simple words, inside the material, the defect may not be visible on the surface, but it would be present inside the surface, inside the material volume. Quick. So in this slide, if you see, all these methods are known as conventional NDT techniques. Right? Now we'll try to see and know few methods which are called as advanced NDT techniques. Okay, magnetic flux leakage, long range ultrasonic testing, X-ray diffraction method. It is also called as XRD, phased array ultrasonic testing, known as PAUT, time of flight diffraction, TOFD, and real time radiography. These are some of the advanced NDT techniques that are used in industry for improving the defect detectability, speed of testing, and getting proper data which can be evaluated later on in the office. So where is this non-destructive testing used in industry? We can use this in fabrication, forgings, castings, plastics, oil, gas, structural, electrical industry, defense industries, or the industries manufacturing defense equipment, nuclear equipment, shipping equipment, railways, and many more. So, in general, if you talk, non destructive testing is used in all industries wherein engineering products are manufactured. Okay, we'll see, try to understand this by some images. See, where applications are flaw detection, evaluation. This is the testing result for dye penetrant testing, that after testing the component will be visible or give some visible indications like this. See, how does defect look in this method? These are the defect points. This is also result of dye penetrant testing, but it is in fluorescent condition, that is fluorescent dye penetrant testing. These are many defects in a welding component. We can use non-destructive testing for leakage detection, that is pressure vessel testing, high pressure testing. This is a vessel that is being tested using high pressure water, that is called as hydraulic testing. The pressure over here is 1500, or this is 1500 1000 psi, pound per square inch. Next, non-destructive testing can be used for dimension measurement. We have seen this image earlier, that how dimensions are used or dimensions are checked using ultrasonic thickness gauge. We'll study this thing in details when we study the method ultrasonic testing. The next application is microstructure characterization. Thereafter, estimation of chemical content, that is chemical analysis. You have a small equipment, you just touch this equipment to the component, and the equipment screen will show you various chemical contents of the material like this. Here you can see this is SS304, and what are the chemicals? Chromium 17%, nickel 8%, manganese 1.48, and copper 0.28%. So by such advanced techniques, quick results are possible, and immediately, without taking any sample, making any scratch on the material, or cutting the material, we are able to check the chemical composition. This is for another material, SS316. What is added over here is moly. Earlier, molybdenum was not there, titanium was not there. So these two elements are added when it becomes SS316 material. Next application is stress or strain analysis, which is also called as dynamic response analysis. Damage assessment or safe life assessment. If there is some fire in a building or a steel structure, then we have to check whether this building or the steel structure can be used or should be discarded, and this is called as damage assessment. So we have some damage assessment pictures. This damage assessment can be done by using various NDT techniques. So I'll show you a larger picture. This was a windmill that was damaged in fire, and then we had to check whether this windmill structure, that is steel, is in a good condition to be used again or should be scrapped off. This was done by using microstructure test. Okay. So when and why non-destructive testing methods are used? NDT methods can be applied to every stage in production or life cycle of the product component. Some of the listed stages of the life cycle of component are assist in product development. That is, it can be used for as a tool in reverse engineering, screen or sort incoming materials in process and purchase. That is, during your incoming material or whenever whatever you purchase, it comes to your company. You have to check whether the material which is received is same as that you ordered, and this is done by NDT methods. Monitor, improve, and control manufacturing processes. Again, this is in process inspection. Verify proper processing such as heat treatment or change in grain size. It is used for verifying assembly. Example is nuclear, medical science, and defense. In medical science, widely we are using CT scan or radiography testing if you want to check the internals of human body, or in other words, after having a surgery and placing the implants in our body, if we want to check they have been placed properly and there is no problem that is created by these implants in the body, we generally do it using radiography. Now, in defense, the example that is very easily understandable, that you can understand it easily, is the bullet. The bullet is filled with ammunition, and we have to check each and every bullet for fully or filling of this ammunition. If any of the bullet remains empty, then it would misfire and not will also block the gun or the equipment instrument weapon that you are using. Next is inspection of in-service damage due to heating, vibration, stress hardening, and so on. Remaining life assessment, or it is called as safe life assessment for existing equipment. This example we have seen in previous slide. So these are few examples where NDT was not used properly. These are the two accidents: railway foot over bridge accident. This was very modestly reported by media that some foot over bridge in Mumbai railway station had collapsed. This happens because we don't do our work properly. All, all the old structures are required to be tested using one or more non-destructive testings routinely, that is repeatedly at some specific interval of time. But if this is not done properly, then it may cause a very huge accident and sometimes take lives of many human beings also. Okay, so this is about introduction to the non-destructive testing. We'll try to understand one method that is used commonly with all the methods, because eyes are the basic tool for visualization, and therefore visual inspection technique is the most important technique in non-destructive testing. I will show you one video hereafter that gives information regarding visual inspection, its application, and the importance. Okay, thank you. I will go to the video.